Before we start working on the project, let me quickly have a look at REST APIs and the other knowledge you gain throughout the course. Is that now all redundant? We learn about things like setting up our Node and Express app, routing, handling requests, responses, request validation, database communication, file handling, uploads, downloads, sessions and cookies, and authentication. These are some big topics we covered throughout the course. Now, how do we have to adjust our knowledge now that we build a RESTful API instead of a view-based application? Well, regarding the general setup, we already saw that in the last module. There are no changes we need to do. We still set up a normal Node and Express server. Regarding the routing, we also have no significant changes. We just use more HTTP methods, more HTTP verbs now. That's the only difference in the end. For handling requests and responses, you already learned that now we work with JSON data instead of views. So that is a difference. We render no views anymore. We have no views folder anymore. We don't use EJS, handlebars, or anything like that. Instead, we only exchange data. So that is a change, but as you learned in the last module, this is also not too hard to implement. Now, if we want to add validation for incoming request data, then we will not have to change anything. We still can add validation, for example, with Express Validator, which we used in the validation module of this course. And the way we use it and the logic behind it does not change a single bit. Database communication, so working with a database, be that a SQL or NoSQL database, also does not change. This happens on the server side in a controller action typically, and the logic we write there, the code we write there, is not affected by the data we exchange or by the fact whether we render a view or if we send around JSON data. When we talk about file uploads, downloads, and so on, there's also not much that changes. On the server side, nothing changes actually. On the client side, the logic changes a little bit, and I will show you how we can implement file upload and of course also serving files in this module. Now for sessions and cookies, there we have changes because we will not use sessions and cookies anymore with REST APIs. The reason for that simply is that you learned about these RESTful principles or these REST API principles, and one of them was that each request is treated separately. It is looked at independently from previous requests. So we have no connection between the client and the server. We have no shared connection history, to be precise. And therefore, we manage no sessions on the server because the REST API does not care about the clients or whether that client connected to the API before. And therefore, authentication will also have to change. We'll use a different authentication approach, and I'll show you which approach this is and how to implement it in this module too. So overall, there are not too many changes. Some changes, the biggest changes, are related to sessions and therefore authentication, and I will show you how to implement them, but the rest will still work the same you learned it, and therefore all the knowledge you gain throughout the course is of course everything but redundant. It's still super important. And with that, let's dive in. Let's see which project we'll be working on and how we can work on it. Attached to this video, you find a new project, and this is now not a Node.js project. Instead, this is now a React.js project. React.js is a front-end JavaScript framework. It runs in the browser, and it allows you to create such a single-page application, which I mentioned in the last course module. You can simply download the attached project, extract it into a new folder, and then navigate into that folder in a terminal, or simply open that folder in an IDE like Visual Studio Code in a new window. And then inside of that extracted project, run npm install to install all the dependencies of that project. Now, I mentioned that this is not a Node.js project. Why do we need to run npm install then? Because it's pretty common that we manage any dependencies in JavaScript projects, even for browser-side projects, with npm, with the Node package manager. The packages I'm installing here are only packages that are getting used in the browser though. There are no Node, Express, or anything like that packages beneath them. Indeed, if you have a look at the package.json file, you'll only find React-related packages here, which do run in the browser. So don't be confused by the fact that we're using npm. These packages here still only run in the browser, and we're just using npm to install these packages. Because in modern front-end development, you have very complex setups, you have very complex package dependencies, and using a package manager like npm can speed that up. Now, once you ran all of that, you can run npm start to start a development server, which is now actually a Node.js server serving your application, but it's not related to the Node server we will build. It's not related to our backend. This is only a dummy development server, which simply serves the built version of our front-end application. So it serves a simple HTML file, which you can actually see in the public folder, this one, which does not have a lot of content, which is what I mentioned earlier, or in the last module actually, that single-page applications have very trivial HTML files. But we have some hooks here, which are used by the React application, which is built in the source folder. There is the source code, and that will be mounted onto these hooks here automatically in the browser, which leads to an application like this. You'll see an error by default when you first start this up. We'll fix the error throughout the module. And there you will see this interface. And this interface is now fully rendered through React.js. If you inspect the source code, so if you view the page source, you will find the HTML page I just showed you with these hooks, and then a couple of script imports at the bottom. And if you inspect the DOM though, you will see way more HTML elements. And these are all rendered dynamically by React, so by that browser-side JavaScript framework. And if you want to learn more about React, I got a whole course on that, of course, so check that out. We'll not write React code here. Almost all the code we'll work with is already prepared by me. We'll just have to tweak some things as we create our REST API. But this is the front that we'll use together with our REST API. And the idea, of course, is that you get a feeling for how front-end and back-end, so the React app and the REST API, are decoupled and can still work together now. So this is the project we'll work with. It's a very simple social network blog messaging-like application. We can have our user status, which we can update here. We can create new posts here. We can later also edit and delete posts. And we'll later also add authentication. Right now, nothing is working because I got no backend attached. This is also the reason why we have an error message right at the start. But we will get rid of that throughout this module, of course. So this is the front end. And this is now the front end I want to connect to my backend. So let's now see which kind of RESTful API endpoints this front end could need before we then start implementing them step by step. So let's analyze this React application to find out which REST API endpoints we want to provide. Now, you don't need to know React for that, no worries. The app.js file is essentially our entry file where our React application starts, or where it basically starts rendering the first screens. And there we also have some logic on which we'll have to work on later. For example, for logging users in, we'll later have to insert a real URL here that allows us to do that, and the same for signing up and so on. Now, in the pages folder, you'll find a feed folder, and there the feed.js file is what's responsible for this page with the new post button and so on. There, we also have a couple of routes. For example, here, where we fetch the status of the currently logged in user, but then also additional routes for loading existing posts. Here, where I want to reach some URL that serves up some posts, but also later down hooks or methods where we can edit the user status, where we can also add new posts or edit existing posts. We'll do this in the finish edit handler, and where we can delete posts, something we'll do in the delete post handler. There you already see I have a couple of fetch methods set up, but the URL is always missing, and that is something we'll have to do, of course. We'll have to add our own URL and make sure that this works, or that we have the respective endpoints for that. On the single post screen here, we load a single post if we click on it. And there, indeed, we also want to reach out to the backend and fetch data for that single post. So in short, which endpoints will we need? And now I switched back to my REST API, which we started building in the last course module. You also find this snapshot attached to this video. There, I already got a route for getting all posts and for creating a new post. That is great. We will also need routes for getting a single post, for editing a single post, for deleting a single post, and we'll also need routes for logging a user in, signing users up, so creating new users, for viewing the status of a user, and for editing the status of a user. These are the routes we will need. And with that, let's start working on that and let's implement them step by step. We already got a route to get posts and to create a new post, which does not sound like the worst start. Let's maybe continue with these so that we can start implementing the appropriate code in our React application to get posts and to create posts. So let's start working on the REST API again. And for that, I'll run npm start in my REST API Node.js project too. And that is also the reason why I'm using different ports, by the way. Here, I'm starting the application on port 8080. My front-end application automatically takes port 3000. And this simulates that these two ends of my application are served by different servers in the end, which is a pretty common scenario since front-end only applications like React can be served on so-called static hosts, which are optimized for applications that only consist of HTML, JavaScript, and CSS, and hence you might indeed have two different servers, even if you created both the backend and the frontend. So we have different ports, and therefore we have different domains, and therefore we definitely need our course headers, otherwise nothing would work. And with that, we can now start working on our feed routes. We actually got two routes already, /posts and /post, for creating a new post and for getting existing posts. And now let's add some logic to our controller actions to actually return something useful and to enable the user to create new posts. Let's maybe start with getting posts, because that would allow us to see at least some dummy data. So that is something useful. For that, in getPosts, we actually already return a list of dummy data posts. Each post has a title and some content. Now, it's of course always up to you how you want your data to look like in an application. In this application, because my frontend also expects it, I want to have a post which in the end consists of a title, which has a user attached to it, a creator or an author, which has a creation date, which has an image, and which has some content. This is what I want to output in my front end, so the data we store on the server should have all these fields in the end. Now, we don't have to start with the full package, though. I already have a title and content here. Now, let's maybe add some image URL here. And for that, I'll create a new images folder. And for the moment, I will just copy an image into that folder. Later, we'll, of course, add image upload. I'll copy my good old duck image, which I used before in the course. And here it is, the lovely duck JPEG. And I want to serve that duck. So here in image URL, I will actually provide images/duck.jpg as a path. Because that is my local path on the server here. It's missing my domain and so on. We'll have to attach this on the front end. But this is now a post as I could serve it. If I now save this, we can actually fetch that data with a GET request to localhost 8080/feed, because that is what we have as a filter to reach the feed routes. So /feed/posts. Now let's try that out in our front-end application. There, we fetch our posts in the feed.js file in the source pages feed folder. In there, you should find a load posts function. Load posts is a function that is called by the React code and so on in the end. And what we do here is I also support pagination, which we'll add later. For now, I just want to reach out to my URL, which is HTTP localhost 8080, written like this, and then /feed/posts, like this. So this route I just talked about in the REST API. This should fetch all these posts. Then here, I just check if the status code is not equal to 200, which would mean that something went wrong. And then I throw a new error, which is handled in the React application. Otherwise, I extract my body. And then here, I have my body, and I use some React logic to load that body in the end and to hopefully display it. If I save that, and I go back to my application, I'll get an error regarding the name, the author name, which is missing. I'm not supporting users yet, so this will be a problem for the moment. And we'll also get an error regarding the date eventually. So to avoid this, we should go back to our controller and add some dummy data for this too. Let's add a creator object, because that is what I'll be looking for in my React code, which should be an object with a name where you can enter any name you want. Later, we'll of course connect this to a real user in the database. And let's also add a date. And here you can simply create a new date with, well, new date like this. Last but not least, you also want to add some ID, and that should be _ID, because I'll be looking for _ID in the front-end code in the React application, because later we'll use Mongoose again here, and that of course, or MongoDB in general, and that of course simply adds IDs with _ID. So here you can enter any ID you want. Now if you save that updated controller code and the server therefore restarts, you can reload, and you'll still get that error, which is related to our status, our user status, which we still can't fetch. But if you simply click that away, you see that first post here, and that is looking better than before. The invalid date is a problem because actually the field should be named created at, not date. That was a tiny mistake on my side. On the server, it should be created at. With that, if you reload, you see this post. So fetching posts works. Of course, it's just dummy data though. To work with real data, I want to be able to create new posts by clicking new post. So that is something we can add as a next step. Let's make sure we can create new posts so that this new post button does not only open the modal, but we can actually add a new post. For now, without the image upload. So let me go back to my REST API, and there we already have a create post route, of course. So we can continue working on that. We expect a title and a content there, and for now this is the only data which I will really need to worry about. Because, well, as I just said, we'll not worry about the image for now. You can pick an image here, but ultimately, even though it's previewed here, it will not be uploaded. But it does not matter. We can implement this in a way that at least the title and content is uploaded. For this, we already got our route in place, a post route to feed post, and there we then extract our title and content, and we, well, for now, basically echo back that message. Let's try that. And let's go to our front-end application, so to the React code. And in there, let's simply go to the feed.js file. And there, you should find a finish added handler function. This is the function which is responsible for handling the case that we clicked on accept here once we entered a valid title and content. By the way, here, I also got validation in place, front-end validation, which is not the matter of this course because it's not related to Node at all. It's just a user experience thing that we use browser-side JavaScript to validate the input right away. You can learn more about that in my React course if you want. Still worth noting that we have some validation in place here, not validation on the server though. So if I now click accept, I want to reach my /feed/post route. For that, here, we have to edit this URL. This URL here will actually be required later when we start editing posts. For now, we want to create a new one. So here, the URL will be HTTP localhost 8080, so our backend URL, /feed/post. This is the route we set up on the backend. Here we send a fetch request to that URL, and we need to configure that request because it will be a post request. So the method here can be post, but actually I'll write this in a more flexible way too, because when we later edit this, we'll use a different method. So here I will create a new variable method, which I'll set to post, which we then later could override in here. So here I'll not hardcode post down there, but instead use my method variable. I will also need to add a body, the data which I want to set. And that has to be JSON data, so I will use JSON stringify to convert a JavaScript object to JSON, and then I pass a JavaScript object here. And this JavaScript object, in the end, should hold the code which I want to, send to my backend. In this object, for now, I simply want to set my title, and that can be extracted from post data, an argument I receive in this function. So post data will hold the data the user entered, post data title, and then here also the content to post data content. So this is again what we add in the React application. Last but not least, to send this request in a way that the server understands it, we need to add some headers here where we set the right content type. So here I'll set content type to application JSON to inform the server that I do indeed send some JSON data. So with that, I'm targeting the right URL and I'm sending JSON data and I'm sending a title and a content. This should be everything I need on the server. So let's save this, and it should reload automatically as long as you keep npm start running here. And therefore, it reloaded the app here. And let's create a new post. The title has to be at least 5 characters long. So has the content. Choose a file, otherwise you're not allowed to submit this, even though the file is not getting uploaded right now, and click accept. Now, you will run into an error here, which is related to the front end missing some crucial data it needs to update everything correctly. However, let's go back one step, and let's actually console log REST data here, still in that finish edit handler, just in a then block after fetching, and save again. The app will reload, and you can enter something into that new post modal again, testing again, and hit accept again. You'll get that same error, but before that error, you'll see a log which actually proves that on the REST API, everything worked correctly. You get back that post created successfully message and the post with the data you entered. The error is simply stemming from the fact that on the server we're not doing everything we expected to do because we're not creating or we're not attaching a user, we're not creating a date, and so on. These are all things we can fix though by going back to our controller on the server. And there, when we create a new post or when we echo back that post, first of all, it should have an underscore ID, not an ID. It should also have a creator field, which is, again, a JavaScript object with a name of your choice. And later, this will not be dummy data anymore, but real data. So we add this creator, and we should add a created add field. And that created add field is simply a new date. And now with that being echoed back, if we save that server-side code and we reload the front-end application, we can test this one more time, click accept, and now we don't get an error. Instead, we see our post there. So now we indeed do create our data on the server, or at least we fake to do so, and we return that back to the client where we can now render it. Now editing will not work, though we can select it for editing at least. Deleting will also not work and viewing will neither, but we got our basic flow set up. Now, since we're creating a new post here, what is missing on the server though? At least 2 things are missing. And what is missing? Well, validation, server-side validation. We only got client-side validation, but that can always be tricked because users can see your browser-side JavaScript code. They could disable it. They could basically find ways around that. So it's not a safe mechanism. It's only meant to improve user experience. So we need to validate on the server. And of course, we want to store the data in a real database. So we should add MongoDB or a SQL solution again. And that is what we'll do over the next lectures. So validation and a database is missing. Now I'll start by adding validation here. And for that, I'll quit my server-side npm start process because I need to install a new package. And I'll use the same package which I used in the validation module of this course. Therefore, you should definitely watch that module to learn how validation works, because I'll not repeat everything here. We already learned it after all. So here I'll just install that package, which was Express Validator. That is a package that helps us with implementing validation into our Node Express applications. After that is installed, you can restart npm start. And now, do you remember how you add it? Have a look at this module I just mentioned if you don't. You go to your routes, and there you add some middleware which does that validation. For that, you first of all need to import something from the Express Validator package, and there from the /check sub package. And that something is either the check method or the body method to check the request body, or with the check method also the headers, the query parameters, and so on. I want to check the request body here. Now, for the get route, validation makes no sense because no data is submitted, but for the post route, it makes sense. And there I'll add an array of middleware that will be applied, which will be related to validation. There, for example, I will use body to check the title field. Now, the title field can be validated in any way you want. I can tell you that on the front end, however, I am validating that title field. And you can see that in the components, feed edit component, that I am validating this to have a minimum length of 5 characters and to be non-empty, which is of course the case if it is at least 5 characters long. The content also has to be 5 characters long. So that's just a little side note on what I'm doing on the front end, and the back end should of course meet that same pattern. So my body title will first of all be trimmed to not have any white space in there. And then I'll use the isLength validator with an object to set a minimum length of 5. Now, this is the title. Now, after a comma, I'll add my next middleware where I will validate the content. We can also trim that and basically set the same validator. Obviously, you can be more creative than that, but I just want to reiterate how validation works and really show you that it works in exactly the same way in REST APIs, because you build a normal Node and Express application in the end. That does not change here. So with that, we added these 2 validation steps for our incoming data, for the title and the content, and now we can implement some logic to send an error if our server-side validation logic is not met. For this, we go to our controller, to the feed.js file in the controllers folder, and there we also need to import something from that Express Validator package. So here I also require Express Validator /check, and that something which I'm importing here is the validation result function. With that imported in create post, we can simply create a new errors constant and use that validation result function on the request. It will then automatically extract any errors that validation package gathered. We can check if not errors is empty, which means we have errors. If that is not empty, we have errors. And then it will return a response with a status code of 422, which is of course our validation failed status code, where I send some JSON data. And there you can have a message of validation failed, entered data is incorrect, or whatever you want. It'll be on your front end to do something with that message or not. And you could add the errors here by using that errors constant and then using the array method to extract an array of errors and also add this to the JSON object. So with that, we're returning this response if validation fails. Now, thanks to our client-side validation, with the correct rules, we could not reproduce that because I'm already checking for a minimum length of 5 on the front end. But if we increase the title minimum length to 7 for now on the server, now if I go back to the front end and I enter a title which is only 5 characters long, and therefore long enough for the client-side validation but too short for the server-side validation, which is of course a mismatch you don't want to have in a real app, but it's great for testing. If I do that and I accept here, I actually get an error, creating or editing a post failed. That is an error message I'm just showing on the front end. But if we have a look at our console log in the dev tools, we see a 422 error here. And if we click on that, we're taken to the network tab. We see that red request. And if we inspect that, we see our response here. And that indeed has that message we sent on the server side, validation failed, and so on. And it has this errors array where we see that the title failed. So you see that the server-side validation is working, and that is all I wanted to show you here. Of course, I revert back to 5 characters minimum length on the server now too, so that the client-side validation logic and the server-side logic are in line. Otherwise, we would have very bad user experiences because users get the feedback that their input is correct, and then the server would throw an error. So with that, we added validation for this post route, and now we can move on to adding a database. So time to add some database logic. And I will again use MongoDB and Mongoose, and I will use that same MongoDB Atlas server we configured earlier in the course. So go back to that MongoDB module if you wanna see how that worked. And if you wanna use MySQL or something like this, you can of course also take the knowledge you gain in the MySQL related modules of the course and implement your own SQL solution here. To follow along smoothly, you should use MongoDB though. I will again use the Mongoose package. So let's install it with npm install --save mongoose. And that will be required to connect to the database and to then, of course, also create our Mongoose models, store data, and so on. I'll restart npm start thereafter. And now, first of all, let's connect. For this, let's open the app.js file and let's import Mongoose here by simply requiring Mongoose. Now, as you learned in the MongoDB and the Mongoose modules of this course, we then establish a connection by using Mongoose connect here. And now we need a URL, a connection URL. Now, as I mentioned, I'll use that same connection URL I used before in the course. So that does not change. I will just copy that. Here it is. That is my Atlas server to which I can connect. And this now establishes a connection. And then I can add a then and a catch block. Catch in case this connection establishing fails. Then I want to log the error. But if we are successful, if we are in that then block here, then I will start my Node server and start listening to requests. If we save that, it now gets restarted and it should succeed. You can ignore this deprecation warning here, by the way. Now we're connected to Mongoose or to MongoDB through Mongoose. And now what can we do? Well, we have to create some models to work with, right? Because that is how we interact with the database ultimately. So let's create a models folder here in our Node REST API. And I'll create a post.js file in there to define how a post should look like. There, I will simply import Mongoose by requiring Mongoose from the Mongoose package. We can then extract the schema from that Mongoose object, that schema constructor, and use that to create a new post schema. You can name that however you want, but you use new schema to now define how a post should look like in your database and in your application. Now, you can of course define this in whichever way you want. I want to have a title in there, which will be of type string. And you learned all about that schema declaration thing in the Mongoose module, so I'll be walking through that a bit faster. So type will be string, and let's say it's required. We then also will have an image URL or image or however you want to name it, and that will also be a string. It will be a URL pointing at that file, and this will also be required. Now we'll also have a content, of course, where the type is string as well, and which also is required. So thus far, not too exciting. Now, I also will have a creator here, and that will later be a link to a user. For now, I don't have that. So for now, it will just be an object and be required. But this is only temporary. We'll change this later. So this is my current setup. Now I will pass an option to the schema constructor, which we haven't seen before. We can configure this. And in that object I'm passing as a second argument to the schema constructor, I can add the timestamps key and set this to true. And Mongoose will then automatically add timestamps when a new version is added to the database, when a new object is added to the database. So we automatically get a created at and updated at timestamp out of the box then. And you can learn more about that feature in the official Mongoose docs, of course. Last but not least, we now need to export this. And you learned that we don't export the schema, but a model based on the schema. So I use Mongoose and then the model method to create a model based on a schema. You can name that model however you want. I'll name it post, and therefore this will create a post database. And I will export my post schema here, or use my post schema. So this is the model defined. One important note about my connection string, by the way, in app.js. There, I'm connecting to a database, and I will connect to my messages database. You can name this however you want. So now we'll connect to this database, and thanks to this model, there Mongoose will use a posts collection for us when we start using that model. Well, speaking of that, let's start using that model in the next lecture. Well, speaking of that, let's now use that model. We're exporting it here. Let's now use it in the feed controller. There, we first of all need to import it. So here I'll import post by requiring it from my models folder from the post file. And now we can use that post model in create post after we validated the input here. There, I will create a new post with my post model as a constructor. We pass a JavaScript object, and there we define basically what we do down there. So we can cut that and move it up here. I don't need to set created at, because Mongoose will do that for me thanks to that timestamps option we set here. And of course, I don't need to set _ID because Mongoose will create that for me as well. Title and content should be passed, and the creator as well for the moment. So now you learned that we can just call save on the model to save it to the database. And this will give us a promise or a promise-like object where we can catch any errors. And here I will log the error for now. We'll later add real error handling, of course. And I get a result, which I also want to log here. And I will also send my response, in here in the then block. I'll send a response. 201 is the status code. The post object here, however, will be the result object I get back here, because that should be my created post. If we now save that server-side code, and we go back to our front-end application, we shouldn't need to change anything in our React code. Instead, we can just try this. Does this work? Let's choose an image. Upload still does not work. We'll do this later. Checking it. And this seems to fail. If we go back, I see path image URL is required, which makes sense because in my model, I set image URL as a required property. So in my feed controller, when I create a new post, I should also add an image URL here. And for now, that can point to images duck JPEG. We'll later add file upload, as I mentioned. So my mistake, we should add this on the server side. Make sure we store an image URL so that we meet the requirements of our model. And now, let's try this again. Does that work? Take the duck, enter some content, click accept. This looks good. Post created successfully. And there we see indeed, this is the data or the post which was stored with the creator, the content, this automatically generated created at and updated at timestamp, thanks to the timestamps option, and the automatically generated ID. So that is working, and on the server side I also get no error, I only see that created object being printed thanks to the console log. So that is working fine. Now as a next step, we can work on serving that image and on accepting image uploads and on handling that error. So let's make sure we can serve that image and in the future also accept image uploads. Now for serving that image, we have to make sure we serve that images folder statically. At least this is the approach I want to use. You learned all about that in my file uploads and downloads module, and the general logic there still applies. So check that out to learn more about that. In app.js, I want to set up static serving of my images folder. For that, up there, after I registered my body parser, I'll use another middleware, and I will do that for any request that goes to /images. Here, I'll use a middleware built into Express, the static middleware, which I use by calling the static function. And now I want to serve my images folder. For that, let's import the path package, the core path package Node provides. And then here we can use path join to construct an absolute path to that images folder. By using the special dir name variable, which is available globally in Node.js and gives us access to the directory path to that file, to the app.js file. And in that same location as this app.js file, we find the images folder, so we can pass images as a second argument, and path join will construct an absolute path to this images folder. And that is the folder we'll serve statically for requests going to /images. With that, we should be able to use our image in the front-end code or to see it. If we save that server-side code, to view the image on the front-end, however, we'll need to be able to click view here because the image will only be included on the detail page. And that, however, will not work because we need a route to serve a single post, which we don't have yet. So we'll have to postpone this. It will actually be what I work on next. But before we do that, I want to set up proper error handling. In the feed controller, right now, when I catch an error here, I log it. And there, when I validate the input, I return an error response manually. You can do that. And you could also return your own error response down there. But you learned that you can set up a general error handling function in Express.js. And I want to use that function. Now, how do I use it though? Let's maybe start with validation. Instead of returning a function manually here, I will create a new error object with new error. And the message I set up here is the message I'll pass to my error object. I'll then also add my own custom property, which you can name however you want, and I'll name it status code and set this to 422. Now, I will throw that error, and I can remove that return statement. Now, what does throwing an error do here? It will automatically, since I'm not doing this in an asynchronous code snippet or anything like that, it will automatically exit the function execution here and instead try to reach the next error handling function or error handling middleware provided in the Express application. We also got another possible error, and that is in here if something goes wrong with storing the post. There, I don't want to log the error. Instead here, I will check if my error has a status code field, which it will not have. But theoretically, if I had more complex code where I throw my own errors, there might be some error that has it. So I check if that exists. And if it does not exist, hence the exclamation mark here, if it does not exist, I will add it. And I will set my status code to 500 then, because it's some server-side error. Now you learned that since I'm inside of a promise chain, so inside of an async code snippet, Throwing an error will not do the trick. This will not reach the next error handling middleware. Instead, you have to use the next function here and pass the error to it. And this will now go and reach the next error handling Express middleware. Now the last step is that we register that middleware. And we do so in app.js. There, let's go all the way to the bottom after all my routes here. And let's use a new middleware which has this error handling definition of getting an error as the first argument and then request, response, and next. This will be executed whenever an error is thrown or forwarded with next. And here I want to log it so that we as a developer can see what's wrong in an easier way. And then I'll extract my status code here from error status code, so from that error object. I'll extract my message from error.message. This property exists by default and it holds the message you pass to the constructor of the error object. And now I can return an error or a response with the status code of the status I extracted. And we can set this to a default value of 500 with this syntax, by the way. So in case this should be undefined, it will now take 500. So we return this status code and we use JSON data, of course, where I have a message of the message I extracted. And now I have this general error handling functionality, which should work, which I can quickly validate by going to my feed routes and changing that validation logic again to 7 for the title as a minimum length. And now let's try to enter a title that is not long enough. And let's see if we now still see an error. We do. We still get that error being thrown with the right status code. So this works even though I'm now using my custom error handling function, which is a bit of a more elegant way of handling errors now. So this is working. Let's now move on to creating the route for getting a single post so that we can finally also see if we can see our image. So time to add a new route in the feed.js file in the routes folder. There I will add a new get route, and that will be a route for a single post. So the route is get/post, and then we need a dynamic parameter /post ID, for example, because we'll encode the ID of the post we want to fetch in the URL. So this is my path. Now we need a fitting controller action. So let's go to the feed controller. And in there, I'll export by get post controller action with request, response, next. And here, first of all, let's extract the post ID from the incoming request params. So there I can get my post ID. Post ID here, this property I'm trying to access has to match exactly the name I assign in my route. So post ID here after the colon. So now I'm extracting that post ID here. Now we have to find a post with that ID in the database. So let's use our post model and use the find by ID method to find a post with this post ID. We then have a then block or a catch block, depending on whether this fails or not. In the catch block, I'll use that same logic as I used for creating a post. I check if we have an error status code. If not, I add it. And otherwise, I just next my error. And yes, you could refactor this into a single function, which you then always use. So here I have this error handling code. In the then block here, I will get my post. And first of all, I'll check if this is undefined. So if this is not a true-ish value. If it is, I know that no post was found. And then I'll actually throw a new error. So I'll create a new error object. Could not find post. I'll set the status code to 404 because that is a not found error. And now I'll throw the error. This can be confusing because I'm inside of then, and you learned that you should use next in there. But if you throw an error inside of a then block, the next catch block will be reached, and that error will be passed as an error to the catch block. So all I do with throwing is I end up in this function, and there I do indeed next the error. So I just always use that function, that's all I'm doing. I still throw an error if I can't find the post. If I do find it, I will return a response with a status code of 200, which shows that it was a success, where I do return some JSON data with some message. You don't have to set a message, by the way. This is purely optional, of course, where I say post fetched and, of course, my post, like this. So I'm returning the post I'm fetching here as a property post in that object. So now we have that controller action in place. Now if I go back to my routes, I can assign that controller to that route here. So feed controller get post is the action I want to use. And this will not work, however, because in my front end, I fetched the wrong posts. I fetched some dummy data because in my feed controller get posts, I'm not using the database. I'm instead just returning dummy data. Now, since we are using a database now, since we have added a database, we should of course fetch data from there as well. So for that, let me use post find to find all posts. And then I have an error or a success case. If I have an error, I'll use that same logic I used down there to add a status code if it does not exist and then next the error. If I succeed, I get some posts here, however. And now I want to return these posts. So I will send a response with a status code of 200, where I send some JSON data, and that JSON data will be an object where again I will add a message, which you don't have to, fetched posts successfully, and most importantly I'll add my posts, of course. And the posts I add here are the posts I fetched with post find, so these posts. Now we can get rid of that response down there with our dummy response, reformat this, and now we have this logic in place to fetch the actual posts we have in the database. If we now save that, we go back to the front end and reload, it should load that post. Does that work? Now, of course, we now want to be able to click on view and see that single post for which we already added the route. We just need to adjust our front-end code, so the React code, to load that single post. And you do that in the source, pages, feed, single post folder in the single post.js file. In there, you have component.mount, which executes when this page loads essentially, where we extract the post ID from the URL in the front end. And now we just need to target the right URL here, which is of course HTTP localhost 8080/feed/post/ and then that post ID. With that, we have a GET request that should get us our post. If you now save that and you click on view, you should load your post here. However, the image is not displayed. The reason for that is that we're looking for the wrong URL, or that we're not using the image at all, to be precise. In the front end, in the same component.mount function you just worked in this set state block here, you should add an image key, and it has to be named image because that is a key I'm looking for in that front-end application in the other code which I prepared. And there, you wanna also define that URL to your server, so localhost 8080/ and then use res data.post, accessing the response data, there the post property, which we do use to store our post in get post. We have that post property here, which holds our post. So this is what I'm accessing now in the front end. And there, image URL. That is the key name, how it is stored in the database. Add a comma thereafter and save that. And now this page should automatically reload and you should see that duck. Of course, we didn't upload that, I prepared it, but at least you see it. Now you can go back to the feed and see your posts here. We'll get off that error message later too, by the way. So with that, we got this in place. Let's now work on image upload next. If you remember that slide from earlier, file uploads require no changes on the server side, only on the client side. So what you learn now is not that important to you if you're not working on the client side yourself. On the server side, the logic is exactly the same, or pretty much the same we used before. Let's still implement it again. Here, I'm back in the Node application, and I want to accept uploaded files. Now, in the past, we did this with a special body parser, a special middleware, and that was Malter. So let's install that again with npm install -- save Malter in the Node REST API project, not in the React project. So there we install Malter just as we did it earlier in the course. And with it installed, let's go to the app.js file, and I will implement exactly the same logic as I did before. So I'll go through that really quickly. You should check out that file upload download module if you want to learn all the details. I will first of all import Malter into my app.js file. And with it imported, I will configure some things for it. Maybe here. I will configure the file storage with Malter disk storage to control where the files get stored. And there we have a destination key, which is a function in the end, an arrow function, where I get a request object, information about the file Malter detected, and a callback I should call once I'm done defining the destination. I'm done immediately here, got no error, and the destination is images, pointing at that images folder here. So that's the first thing here. We add another function to the disk storage object, and that's the file name function, which defines how the file should be named. Get the same arguments as in the destination function. And I call that callback with null as an error, and the file name will be a combination of the date, which I convert to a string, and then a dash, and then the original file name. Really simple, exactly the same logic I used before. I'll also define a file filter where I also have, or which also is a function which gets a request, information about the file, and a callback. And in here, I'll check for a couple of MIME types. I'll see if my file MIME type is equal to image/png, or if file MIME type is equal to image JPEG, or if file MIME type is equal to image JPEG with an E. That is my if condition. If anything of that is true, then it is a valid file, and therefore I return no error and true as a second argument in the callback. Otherwise, it would be invalid, and I still have no error, but I return false here. And this is again something you learned in the file upload module. Last but not least, I need to register Malter. And I will use it here, maybe after the JSON body parser. I will use Malter as a function, pass an object to configure it, assign a storage to my own file storage constant we just created, and add a file filter, which points at that file filter constant we just created. On that Malter function, I'll then also call single image to inform Malter that I'll extract a single file stored in some field named image in the incoming requests. Now every incoming request is parsed for that file or for such files. With that, Malter is registered, and now we can use the file in our controller where we create a new post. For that, in create post, I can first of all check if request file, if that is not set, because if it is not set, then I'm missing a file. So I will create a new error here. No image provided maybe. I will set my status code to 422 because it's also kind of a validation error, and I will throw that error. That's the first check. Now if I do find a file, then everything is good. Malter was able to extract a valid file. So then I'll just set up an image URL constant, an access request, file, and there the path variable, which Malter generates, which holds the path to the file as it was stored on my server. And now this image URL is what I use here as an image URL, of course, instead of my dummy data. Now we should be able to extract files and really store them. Let me now run this, but of course now we also need to tweak our front end to be able to make that work. And I didn't do this in advance because there is something special which I want you to know. In the React code, so on the front end, go to that feed.js file in pages feed, and there let's go to the finish edit handler. There, we're setting up everything we need to send a request to the backend to create a new post. And right now we're doing this with JSON data. Now we won't use JSON data anymore because JSON data is only text. So only data that can be represented as a text, which a file can't be, or not easily. It will be very big quickly, and very big files are a huge issue or impossible to upload like this. So we can't use JSON for data where we have both a file and normal text data. Instead, we'll again use form data. Now, we did use form data automatically when earlier in the course, where we had a traditional app with rendered views, when we used a form with this multi-part form enc type, which we added to the form HTML element, if you remember. So this form data is what we'll also use here, but we'll not use anything to any form element. We'll do it all in JavaScript instead. Here, where I have this marker, this comment, we can create a new form data object with a built-in object that browser-side JavaScript offers, the form data object. This now allows us to append data to that object. For example, the title. First argument to append is the name of the field, second argument is the actual data. So here we'll have post data.title, exactly what we passed to the JSON data before. Of course, we don't just append the title, we also append the content. So let's append that. And now we also want to append an image because we can append files as well. Now this should be named image because we'll be looking for this field on our REST API. And now here I can reach out to post data image because that is where I will get my image in my front-end code. With these three fields, I got form data prepared that now has mixed content, text, and a file. And now I want to use that form data as a body for my request. We should not set the header to application JSON anymore because that would be incorrect and would break our app because we would try to parse it incorrectly on the server side. Instead, the form data will automatically set the headers. That is kind of convenient. All we need to do is we need to set form data as our body, and the rest will be done for us. If we now save that and we create a new post, let me create a post here, a duck, and choose that lovely duck image again. This is a duck and click accept. Now this was pretty quick. If I now click view here, I see my duck here, which is looking good. And on the server side, I also see this image which was generated, which has a timestamp, and this is the uploaded image. I got no error here, so this is all looking good. So uploading files also works. As you saw, on the server side, it has exactly the same logic. On the client side, things need to change, but of course, this is a Node course, so it depends on which client you're using, how you need to adjust your code there. We're making very good progress. We're able to create posts, view a single post, upload files, validate content, all great. Now, what is missing? We want to be able to edit posts, we want to be able to delete posts, and authentication and users and connecting posts to users. This is all missing. Now, let's continue with editing and deleting posts before we dive into the authentication and user-related things. So for that, let's go to our feed routes in our Node REST API project, and there I'll add a new route. I want to be able to edit posts now. And for that, I will use a new HTTP method, which we haven't used before. Editing a post essentially is like replacing the old post with a new one. We'll keep the old ID, but that is it. Since we'll replace a resource, I'll use the put method here. And the put method is one you learned about in the last module, but which we haven't used before, because with normal browser forms, you're not able to send it. Through asynchronous requests triggered by JavaScript, you are, however. Now we need a URL here, and the URL will be /post, and then also the ID of the post encoded in the URL, so :post ID. Now we also need a controller action to handle that. The important thing about put requests, and the same is true for patch requests by the way, is that they also have a request body, just like post requests. But you can also have parameters in the URL. Well, that would have been the case for post requests too, by the way. But the important thing is we have a body for these requests. We can add a request body, and that will hold the actual post data that I want to, use and that I want to use to replace my existing post. So let's work on the controller now. In the feed controller, at the bottom, I'll add a new action and I'll name it update post. The name is up to you, but this is what we'll do. We'll update the post in there. This is the function. And in here, in this function, I can first of all retrieve my post ID from my request parents, because we just added it there, right? In my route, post ID is a parameter, which of course I can extract. Now, when updating a post, I also will extract my title, so request body title. I will extract my content, request body content, and I want to extract my file, my image URL. However, for that URL, we have two options when updating. The first option is, and that will be my default, that image URL is part of the incoming request and it's just some text in the request body. That would be the case if no new file was added, if no new file was picked. Then my frontend code has all the logic to take the existing URL and keep that. But we might have picked a file, and in this case, request file will be set, and I can now set image URL equal to request file path. This is the alternative. After all of this, at least one of the two should be set. So if image URL is not set at this point, because we were not able to extract it from there, and we did not make it into this if statement, then we should throw an error. So here I will prepare a new error, no file picked. I'll set my status code to 422, and I will throw that error here. So that's my first little piece of validation. We'll add more validation, of course. Normally, we should have an image URL, however. Now, I have one little mistake here, by the way. This should be image here, what I retrieved from the frontend, and we need to tweak our frontend a little bit too. There, in feed.js, in source pages, feed.js, when we load all posts, so in load posts, that is when we basically load the post data from the server, including our image URL. Now, we then store the posts here in the front end so that the rest of the React application, the rest of the code I prepared, can handle that. We need to tweak this line a little bit. There, you should access REST data posts, but we have to map this, which is a default JavaScript method, into a different kind of array, or every element has to be changed a little bit. Map takes a function that executes on every element in the array, and it gets the element, which in our case is a post, as an argument, and then we return, the updated version of that object. So I return a new object here, where I will use the spread operator to get all the properties of my post object, and then I'll add an image path key here, which is post.imageURL. Now, image URL here is referring to the property I'm storing on my server side. There we're storing the path to the image in an image URL key. You could have named this differently. If you named it differently here, you would have to name it differently here. Now, I'm storing the original path here, because when I'm viewing a single post, for example, I do extract that image URL and I append my URL to the domain. Now the path should be, well, just a path without the domain, because I'm keeping that here, and this will get reused later when we edit this through this edit modal. Behind the scenes, this path will be stored, and if I don't choose a new file here, this path will be submitted with my edited post, and there the path will be stored in a property named image. You can see that in the components, the feed edit component under feed edit. There you could see all the internals. If you know a little bit of React, you can see the internals and see that I'm extracting my image path and I'm storing it in an image key ultimately. I don't want to dive too deep into React, but this is what I'm doing on the front end, and this was one adjustment that was required. And on the server side, we can now extract our image here from the body, and either this is set or we selected a new file, in which case a file will be found. So now we can continue working on update post, and we can continue working by first of all adding more validation, which we do in our routes, of course. Well, there I will copy that array from my post route and I will add it here. So for my put route, I also want to validate the title. By the way, we should switch that back to 5 characters of length for both posting and putting. So I will validate these two things. I'll not validate my image because that is done directly in the controller action. And I don't need to do any other validations for now. So with that added, let's go back to the controller and let's copy the validation logic from the post route where I gather all my errors and then I check for errors not being empty and then I would throw an error. So before I extract anything else, I'll check these things in update post, whether I have any errors, and if I have, I'll throw an error. If I don't have errors, I continue, check the file, and if we make it down here, so after all these if statements, then I know I have valid data and now we can update it in the database. To update it in the database, I will find my post by ID for the post ID which I extracted from the URL. Then I can do something, or we might have an error. If we have an error, I'll reuse that error handling logic you find in other places, in other actions. So I'll add my status code and then next the error. If I am successful, I know we have no database error. I still need to check if post is undefined, which means we didn't find a post, in which case I will also throw an error, just as we did it for getting a single post. I can copy that logic. And again, if you're copying a lot of code, you might of course also refactor that. I like the more verbose approach to make sure we all understand each step we take in each action creator. And if we make it past this if check inside of the then block, then we found a post, and then I want to update the post, of course. So here, I'll set my post title equal to the title I extracted. I'll set my post image URL equal to the image URL I extracted, and I'll set my post content equal to the content I extracted. And then I can return post save here to save that updated post back to the database, overwriting the old post but keeping the old ID. And then here we get the result of that save operation. And here I want to return a response with a status code of 200. We didn't create a new resource, so it's not 201. With some JSON code or some JSON data where I say post updated maybe, and where I return that updated post, which is stored in the result in the end. So this is now the updating logic here. There's one more thing we can add, and that is some logic to delete the image. For that, I'll add a little helper function down there, clear image, which is a function that accepts a file path as an argument. And then I will use the file system package Node.js offers. So I'll import it at the top by requiring fs. And with that imported in that clear image function here, I'll first of all construct my file path, for which I'll also import the path package, by the way. So let's import that at the top too. And now the file path can be constructed by joining dir name, then going up one folder, because we're running this inside of the controllers folder, which is not where we will find images. So we should go up one folder to be in the root folder. And then we look for whatever file path we got here. So images, and then the image name would be the case in our application. And I can then use the unlink function to delete that file by passing the file path to it. And we can also log any error message. And I want to trigger that clear image function whenever I uploaded a new image. So inside of my update post action creator, right before I save my updated post maybe, I'll check if my image URL, which is the path to the image, if that is not equal to post image URL. So to the image URL I stored in my post before. If they're not equal, it obviously changed, so I uploaded a new file. And that is where I will execute clear image and pass the old image URL, so the old path, as an argument. Now with that, we got all in place here in the controller. Now we can go to the route, and there we still need to register that controller action on the put route. So on the feed controller, I'll access update post here. That's one important step. And on the front end, so in the React code, we also need to do something. There, in source, feed.js, in the finish edit handler function there, we need to adjust our code now. There we set up our form data, which is correct for updating as well. But if we are in edit mode, which will be the case if we make it inside this if statement, due to the logic I configured on the front end, we want to send a request to localhost 8080/feed/post/ and now we need the post ID, which we get from this state edit post._ID. That is where it will be stored in my React app. And I'll set the method to put because we created a put route. Now with that, we can save all that and try it out and hopefully not get an error. Let's edit the second duck here and add a couple of exclamation marks in both title and content. Let's not choose a new file. It's looking good. I see my exclamation marks there. I see them in the content as well. Here, I get a confirmation message that looks good. And on the back end, I still only have one image. Well, that makes sense because I didn't replace it anyways. Let's now replace it by editing that same duck again. Let's not change title and content, but choose a different file. Maybe that coffee mug. Click accept. Post updated is looking good. It's not a duck anymore, so the title is not correct, but on the back end, we only have the coffee mug now. So updating seems to work. And of course, we can confirm this by viewing that image as well. There, we also see all the updated data. So that is working. And with that, only deleting is missing before we can finally start working on authentication. To ensure that we can also delete posts, let's start in our Node REST project and add a new route. This will be a delete route using the delete HTTP method. We register such a route by using router.delete. Now here, the path will be /post/:post ID. For delete routes, you can't send a body, but as with all routes, you can of course encode data into the URLs, and that is what I'm doing here. Now the route is one thing. Obviously, we also need a controller action. So let's go back to our feed controller, and before clear image, I'll export my new action, which I'll add, which will be my delete action. So I'll name it delete post here, will be my standard middleware with these 3 arguments being passed to the function. And in there, I first of all extract the post ID from my request params as we did it multiple times throughout the course. Then we can use the post model to find a post by ID, and that will be my post with this ID, of course. Now, why would I find it by ID first? I can, of course, also use post, find by ID, and remove. Well, I will use this eventually, but later, once we added a user, I want to verify whether that user created the post before I delete it. So we'll first of all find the post with success or not, And if I have an error, I'll use that old error handling code I had before. And in the then block, I'll have my post where I will check whether the creator is the currently logged in user. So check logged in user. This is something I can't do yet because we have no logged in user, obviously. For now, there's one thing I can do though. I can use clear image to access the post I retrieved and delete the image for the image URL that is stored there. There's one other thing I actually should do, and that is I should check whether that post exists. So I can copy that logic from up there, where I see whether post is undefined, and if it is undefined, I throw an error. Now, if that's succeeded, I delete the post image, and then I return post, find by ID, and remove, because now I will remove it. And here I pass my post ID again. I can add one more then block with the result of that operation, and in here, I'll know whether that succeeded, and most importantly, I'll return with a status code of 200, which means yes, we were successful, and a JSON data package, where I will just say deleted post in a message. Of course, you could send any data you want. So with that, my delete post action is configured here in the controller. Back in my route, I can now use my feed controller delete post and assign it to that delete route. And now we just need to work on the front end and hook up this route. So there in the feed.js file, which we worked in a lot already, you'll find the delete post handler. And there you simply need to update that URL you see in there. So let's replace URL with HTTP localhost 8080/feed/post/ and then post ID, which is an argument we'll get in this function. Now, important, we want to send a delete request, so we need to pass a second argument to fetch here and set the method to delete. And that is it for now. This should now send such a request when we click the delete button. So make sure you save this and your backend code. And thereafter, let's go back to the feed. And let's click delete, maybe on the first item. Now, after reloading, it's gone here. And the duck image was deleted as well. If I reload this app, we also should not fetch it again. So it really seems to be gone. So now deleting also works. Now, before we actually move on to authentication, there's one more thing we can do on the front end, and that is pagination. So splitting our list of posts across multiple pages. And I want to do that first. Now, for that, we need multiple posts. So let's quickly create a couple of posts, like a cup of coffee. Choose that cup image, which fits it quite well. So tasty, whatever you want, and click accept. And let's add another post, a real duck, because I replaced that image of the other duck, so maybe it's time to add another one. This is a duck. Click accept. And now you see, here I only see 2 posts on the front end. I don't see any more posts than that. If I reload, I see 3, however, but I actually want to limit that. I want to limit the amount of posts I see there and instead pass some information to the front end that allows the front end to show some next and previous buttons at the bottom. Now, all the logic for this was already added to the front end, but on the back end, I need to return different data. I need to paginate my data. For that, we should dive into our controller and there into the get posts method or action, because that is where I fetch all posts, of course. And that is where I want to implement pagination. Now, it turns out that in my front end, feed.js, where I load my posts, so in the load posts method there, I actually do set some pages. I have my own pagination logic in there, and I can pass that page data back onto my backend. I want to do that through query parameters, and I want to do that in load posts in the front-end code. Here, in my URL, I'll add $page equals to add a page query parameter, and I'll add this page variable, which I'm creating up here. And this will be managed internally in my front-end app, so this will be either 1 or 2 or whichever page I'll try to load there. So now I pass that page query parameter to my backend. And there, I now need to extract it to implement pagination. So in my get posts action here, I can extract the current page by accessing request, and then query parameters are stored in the query object, and then page. I'll set this to 1 as a default. You saw this syntax a couple of times. This OR syntax checks whether this is undefined, in which case it would assign this value, so that they always start on page 1. Then I'll set the per page value to 2, and I do this because I have the same value in the front end. Now, of course, you could find a more elaborate solution where you pass that per page data from the backend to the front end so that the front end can adjust dynamically, but here I want to show the general setup and how this works. So I am hard-coded per page here, and I have hard-coded it in the front end. Now I'll create a new variable, total items, which I'll need to determine how many items I have in the database. Because now I'll add a new find request, and I will add count documents here to find out how many documents I actually have. This will not retrieve the documents, it will just count them. Then I can have success or fail. If I fail, I'll have the same logic as before, so I'll check the status code, add it if it does not exist, and forward the error. If I succeed, then in this then block, in this function there, I'll know how many items I have, and I'll store that value in my total items variable. I created that variable so that I can now also use that data in other functions than this function. Because in here, in this then block, I now want to return my old fetching logic so that I first of all count, and once I got the count, I actually find the documents and retrieve them. So here I will return this and all that logic. So this then block, essentially, I'll cut that out. I'll remove the catch block. I'll add the then block after the first then block. And this catch block will now take care about both counting and then this internal finding. However, here I will not just find, of course. I want to add pagination. And the logic is the same as before. We can skip a certain amount of items with the skip method. And there I calculate the current page minus 1 times per page. So that if I am on page 1, this will result in 0 and I skip no items. If I'm on page 2, this will result in 1 and I skip all the items that were on page 1. I also want to limit the amount of items I retrieve with the limit method. And here I take per page, so the amount of items I want to have on each page. This is what I now return in there, and then the posts here are these, well, limited amounts of posts. In my response, I now don't just need to return the posts, though. In my front end, I also have some logic to take the total amount of posts into account, so that in my React front end, I know when to show the next and previous buttons. For that, I'll add another argument to the data that I return in the response. I'll add total items in there. I'll be looking for this total items property in my front-end code, so you should get this right, not misspell it. And the value will be my total items variable. So this variable value, which I assign here, will be stored down there. With that, if I save that backend, if I reload the front end, you now see a next button here. If you click it, we load the next page where we only have one item and I can go back. So now I have pagination added as well. As you saw, in the same way as before, because REST APIs are not that different in the end, just handled differently because we have a separate front end. Now we worked a lot on our posts. I now want to work on my users. And for that, we first of all need to add a new model in our Node project. There, I'll add a user.js file where I define how a user should look like in my application. So here, I'll import Mongoose. And of course, feel free to do these steps on your own. We did them a couple of times. I will access my schema here. And then I'll define my user schema with new schema here. And we'll add some properties, of course. By the end, I'll export a Mongoose model, which I'll name user. Hence, it will get stored in a users collection, which uses this user schema. Now, how should a user look like? Obviously, that is totally up to you. To fit my front end, a user should have an email, which will be of type string and which is required. A user also will have a password, which is of type string and which will be required. A user also will have a name in my application, type string and required, you guessed it. And a user here also will have a status. So status is also of type string and required. That is this thing which caused this error in the front end all the time because we couldn't load it. Now, a user will also have a couple of posts. So I'll add my posts here. This will be an array. And now each object in the array will be of type schema types object ID, because this will be a reference to a post. And therefore, I add this ref key and add the post model. So I'll store references to posts in my users or on my users. This is how a user should look like. If you want, you can also add the timestamps. I don't need them here. So now I got my model set up. We can now use that model to set up a sign up and later also a login route. So let's create a new route and I'll name that user.js or maybe auth.js because it will be authentication related. In there, just as before, we import Express by requiring Express. We then create that Express router by calling Express router as a function like this. And we, of course, export this router. Now, in between, we define our user or our authentication related routes. And there, for example, I want to have a post route. And you could argue that you also set a put route maybe. Let's go for a put route because actually we create a user once. So we could also say whether it's new or we override existing data, we put the data, but both would be fine. Here we'll have sign up as a route, let's say, and then I need some controller, of course. Now, I'll also add validation, and to actually reach these routes, we have to go to the app.js file. And there, where I import my feed routes, I'll duplicate this and also set up an auth routes constant where I import routes auth. And then at the bottom of the file, where I have my feed routes, I'll also add /auth to forward requests that start with /auth in the path to auth routes. Now we are able to reach these routes, and now we need the controller. So let's work on the controller and add validation in the next lecture. I will create a new controller, auth.js, that is related to my users, to my user data, to my authentication logic. And in there, I'll first of all import my user model by requiring it from my models folder, the user file. Now, we need at least two actions here, and the first one is of course the action to sign a new user up. So I'll name this action sign up, and I'll get my request, my response, and that next function. And in here, I'll want to add all the logic I need to create a new user in the database. So for that, let's extract the email from request body email. Let's extract the name of the user from request body name, and let's extract the password from request body password. Now, obviously, to extract all of that, we need to know that it's there. So we should add validation. For this, I'll go to my auth routes again. And just as in feed.js, I will add this express validator check. So we'll copy that import from feed.js and add it to auth.js. And on sign up, I'll then add an array of validation related middleware. I'll check my request body and there the email field, whether it is an email. We can also, just to bring this back into memory, define our own messages if we want to. Please enter a valid email. This would then be stored in the error object we can retrieve. We can also add our own custom validator here to check whether the email address already exists. For this, I'll import my user model. So require that from the models folder. And then custom, and you learned that in the validation module, by the way, in case you want to dive deeply into that again. The custom function, or the custom validator method here, takes a function as an argument which retrieves the value we're looking at, and then an object from which we can extract the request as a property with this destructuring syntax. And this function then should return true if validation succeeds, or return a promise if the validation actually uses some async task. So if the validation does something which takes a little longer, as in our case. So I will return user, find one, and I want to find one user where the email of that user, as stored in the database, matches the value of the email we're looking at. Now then, I have my user document here, so my user object as I found it in the database. And if that is set, and that's the only case I'm caring about, if that is set, then I will reject a promise. So I will return promise reject, and that will cause the validation to fail. All other scenarios will cause it to succeed. And there I'll return email address already exists. So that's just another validation we can add. Of course, I don't just want to validate the email though. So let's also validate another field in the request body. Before I do that though, just one step I forgot. I will normalize the email as well. But now I can look at other body fields like the password. The password can be trimmed and should then have, let's say, a length of at least 5 characters or whatever you want. And I'll add another check where I'll look into my body, there to the name, trim it to remove excess white space. And this should now not be empty. With that, I got all my validation logic added. Now that I'm in here, I can also already import my controller. So my auth controller can be imported from controllers auth. And now I'll use that auth controller as the last middleware on my signup route and reach out to the signup action in there. Now validation was added. Now back in the auth controller, we want to collect any validation errors right at the start. And for that, I need to import something from the Express validator package again. And that will be that validation result function, which I require from Express validator /check. So this validation result function here. And I collect errors by calling that and passing the request to it. And now if not errors is empty, so if we got errors, then I know that something went wrong or that I will have errors. And in this case, I want to create a new error where I say validation failed, something like that. And I'll set a status code of 422. And I can also maybe pass some data, a new property I'll add, where I store my errors array like this. And then I can throw my error here. Didn't do that before, but this would allow me to keep my errors, which were retrieved by that validation package. I now just have to go to app.js, to my error handling function, and there retrieve the data from error, the data property, and also add this to the response I'm sending in case of an error. This is totally optional, but just to show how you could keep your original errors and pass them to the front end as well. So now I'm doing this, I'm doing that validation, throwing an error if it fails. If we make it past this if check, we know we have all that data we need. And now we can start storing the user in the database. Now, there are parts of the authentication module which still matter here. And one of them is that we should encrypt the password. So let's finish sign up in a secure way in the next lecture. To store the password, we should hash it so that if someone gains access to our database, the password is not stored in plain text. For that, I'll install a new package which we used before, and that is bcrypt.js, which allows us to hash a password in a secure way. After this was installed, we can rerun npm start, and now in my auth controller, I'll import bcrypt by requiring it from the bcrypt.js package, and in there, down there in my signup action, I'll use bcrypt, and there the hash method to hash the password, which is plain text here, with a salt of 12, so a strength of 12, so to say. And I'll then continue or face errors here. Now, if I have an error here somewhere, then it'll be a server-side error. I'll copy the logic from before, so from my feed.js controller, where I just check for the existence of a status code. If no status code exists, I'll set 500 and, well, throw that error like this. In the then block, however, we'll have our hashed password, and that is the password I now want to store in the database. So in here, I'll now create a new user with the help of my user constructor, so my user model created through Mongoose. And I'll set the fields I need to set on the user. So that would be email, password, name, status. Actually, we can change the status here from required true to default of I am new. So now we don't need to set it when creating a user. Instead, every user will start with this status here. Just a little adjustment. With that, we don't need to set the status, but we do need to set email, password, and name. So the email is the extracted email. The password is the hashed password, not the extracted one, but the hashed one to secure this. And the name is the extracted name. Now, last but not least, I will call save to save it to the database, and I will return that so that we can add another then block where we get the result of that database operation. And here we know it will have succeeded, so we can return a response with a status code of 201 because a resource was created, where I can return some JSON data with a message of user created, and then maybe the user ID, which I can extract from the result, which is the user object, result._ID. So now we're creating a user here. Let's now save that. And to see that on the front end, we need to go into the front end code and there to the app.js file. And here, first of all, we need to correct our URL. And I also need to change something so that we start in unauthenticated mode. Currently, we are starting as if we were authenticated. I'll have to change that in the front end too. Now, first of all, in the signup handler, let's fix that URL. And there, the URL will be localhost 8080/auth/signup. And that will reach this route here, right? Because it's /signup, and we only end up there for requests that start with /auth. Now, we defined a put request here on the backend, so we have to set the method in the second argument in this object we pass to fetch. We have to set the method to put. We also need to append some data, and that data will be of type application JSON, so we should add the content type header and set this to application JSON. Last but not least, let's add the request body. And here we'll need to use JSON stringify to convert an object to JSON. And that object will be a JavaScript object with the email, which we can retrieve from auth data email. Auth data is an argument we'll get here. And I wrote the code to make sure that we get the data the user entered. So we'll get the email. We'll get the password. So let's also extract that from auth data. And we'll get the name from auth data. So everything which we extract on the server side. This is now all passed to our backend. Now in app.js, scroll up a bit more to the very top. Here in this state, you now should change is_auth to false so that we start unauthenticated. Now, when the page reloads, you start on the login page and you can switch to sign up And there, let's create a new user. You can enter any name you want. And I accidentally hit enter, which is good because we now see validation is doing its job. But now let me enter a valid password, which you should remember, and click sign up. And it still failed. Let's see what's wrong here. Let's inspect for which field we're getting this in the by inspecting the network tab. And then here we see, okay, all 3 fields give us the error. That's kind of a strong signal that the data is simply not passed to the backend at all, so something seems to be wrong there. Indeed, we can validate this by clicking on headers. There we see there's no request payload added to this request. And that's simply a little mistake on my side. In app.js, in the frontend code, in signup handler, here where I extract auth data, email, and so on, that should be signupform.email.value, and the same for all the other fields too. So let's add signupform in front of that and .value at the end. The same for the name. This is how the data is stored here internally in the React app, and this is how we should extract it. So let's give this another try. Let's pick an email address, a name, and a password. And now this looks much better. I get back user created. I'm forwarded to the login page here in my front end. I get that user ID. And of course, we can, as always, use MongoDB Compass to also take a closer look at our database. There, I got this messages database. If I reload it now, I got a users collection in there. And here I have that user. So that is working. The user also has the starting status. Now we have no posts, of course. Now we can continue and we can work on logging the user in. And that will now be the interesting part because I already mentioned that authentication will now work differently. So how does authentication work in a REST API then? Well, we obviously still have our client and server. And the client still sends authentication data to the server. So the email and the password, let's say. In the past, we then would have checked that data on the server, and if it is valid, we would have established a session. Now, we don't use a session anymore because RESTful APIs are stateless. They don't care about the client. You learned about that strict decoupling of server and client, and every request should be treated standalone. That means every request should have all the data it needs to authenticate itself. With a session, the server needs to store data about the client. The server then stores that a client is authenticated. And that's just not how REST APIs work. The server will not store anything about any client. So we don't store sessions on a REST API. And therefore, this approach will not be used anymore. Obviously, we will still validate the input on the server. We'll still check for the validity of the email-password combination. But then instead, we return a so-called token to the client. That token will be generated on the server and will hold some information which can only be validated by the server. And this token will then be stored in the client. So there in storage in the browser, there are specific storage mechanisms for this. And the client can then attach this token to every subsequent request it sends to the server. So this stored token is then attached to every request that targets a resource on the server which requires authentication. That token can only be validated by the server which created the token. And if you change that token on the front end, or you try to create it to fake that you are authenticated, that will be detected. Because the server uses a certain algorithm for generating the token, which you can't fake because you don't know it, or you don't know the private key used by that server for generating the token, to be precise. That token contains JSON data, or JavaScript data in the end, plus a signature, which, as I mentioned, is generated on the server with a special private key, which is only stored on the server. And this gives us a so-called JSON Web Token. This JSON Web Token is then returned to the client, and the signature, as I explained, can only be verified by the server. So you can't edit or create the token on the client. Well, you can, but then the server will detect this and will treat the token as invalid. This is how we generate the token or how we do authentication in REST APIs. We have the token which can be checked by the server, but which does not to be stored on the server. And this gives us an elegant way of authenticating requests in a REST API world. Now let's implement this. To implement authentication, we first of all need a fitting route. So in the auth.js route here, I will add a new route, a post route, where I will log the user in. So it will be /login. We could add validation here, but I don't really care about this because I will check the email password pair anyways. So we can also directly go forward to our controller action. So let's implement that. Let's work on the controller action now. For that, in the auth file in the controllers folder, I'll add a new action which I'll name login, which of course is a function with request, response, next, and then some logic. And in here, as before, I'll retrieve my email, from request, body, email. I'll retrieve the password from request, body, password. And I now, first of all, want to find out whether that email address exists, because if it does not, then we already know that you can't log in. So I'll use my user model and find one to find one user where the email equals the extracted email I got here. We can succeed or we can fail with that. If we fail, we'll use that same handler we used before. So we'll throw an error, because here failing, of course, means that we simply had some network error, some error with the database. If we make it into the then block, we have a user object, but that does not mean that we found a user. It could be undefined if no user was found. We basically always end up in the then block if no error is thrown. So here, I'll check if user is not defined. And if it is not defined, I'll create a new error object where I add a message of a user with this email could not be found, anything you want, where I'll set a status code of, and now you could choose different codes. You could go for 404 because no user was found, or 401 for not authenticated, and then I'll throw that error. If we make it past this if check, we know that we have that email address. Now we need to validate the password. For this, I'll quickly create a new variable, loaded user, and I'll store my user in that variable so that I can use it in other functions later too. Now I'll use bcrypt again, and there I'll use the compare method to compare the password the user entered with the password I got stored, so with that hashed password. So user.password is the password I'm looking for. I'll return this because this will give me a promise, and hence I can add another then block here. Here I get back true or false, depending on whether this is equal or not. And if it is not equal, of course then the user did enter a wrong password. So here I'll create another error. Wrong password maybe. And I'll add a status code of 401 again and throw that error. But if we make it past the if check, then we know the password is equal to the password the user entered. So the user entered a correct password. And now we need to generate such a JSON Web Token. Let's do that next. So we're at the point where we know that the user did enter valid credentials. Now we want to use that information to generate such a JSON Web Token, which I showed you on the slides. For that, let's quit the server here, the Node server, and let's install a new package. The package I want to use is called JSON Web Token, one word. This is a package which allows us to conveniently create such new JSON Web Tokens. We can now restart the server, and we need to import this into this file. So here, I'll import it, store it in a constant named JWT. The name is, of course, up to you. The JSON Web Token package, or the object it exposes. Now down there, after checking the password, I want to generate a new token. I'll store the token in a constant name token. And then here I'll use the JWT package and there the sign method. This creates a new signature and packs that into a new JSON Web Token. We can add any data we want into the token. Like for example, we could store the user email, so access the loaded user email, and the user ID, access the loaded user underscore ID. And since it's a MongoDB object ID here, let's convert that to a string. So now I'm storing some user data in the token. Of course, you should not store the raw password in here because that would be returned to the front end, to the user to whom the password belongs, but still not ideal. Email and user ID should be fine, however. And then you need to pass a second argument, which is that secret, so that private key, which is used for signing. And that is now only known to the server, and therefore you can't fake that token on the client. I'll enter secret here. Typically, you want to use a longer string, like some super secret, or even longer. Also check out the official docs of the JSON Web Token to learn more about it. I'll also set a third argument where I configure this, and there I'll set an expiry time of 1 hour with this syntax, so that the token becomes invalid after 1 hour. Now, this is a security mechanism you should add, because the token is stored in the client. Now, of course, by the client to whom it belongs. But technically, that token could be stolen. If the user does not log out, another person copies the token from his browser storage and then can use it on his own PC forever. Well, not forever now at least, because after 1 hour, the token becomes invalid. So this is a good security mechanism, which is like a nice finds a nice balance between usability, where you would want infinite sessions, and security, where you would want to limit this to like 1 second. Now, this is a nice in-between solution, which is pretty common. So now we have a token which we can return to the client. So here indeed, I will now return a response with status code 200, where I add some data. We can add a message if we want, but I will only add that token which I generated and a user ID. And that is my loaded user dot underscore ID to string. Now that data needs to be provided because in the React app I gave you, I'll be looking for that ID and I'll be storing it. By the way, it should also take 1 hour because in that React app, I'll log you out after 1 hour. And all that storing and so on will be done by the frontend. Now I'll show you how it gets stored in a second, of course. So let's now go back to our auth route and connect our login route to our auth controller and there the login action. And now with that, let's go back to the front end and work on the code there as well. So in the front end, here in the app.js file where we have the sign up handler, we have to look for the login handler here, and we should fix the URL there too. The URL is localhost 8080/auth/login. We need to pass an object where we now also change the request method to post and where we pass our data. So just as with signing up, we can actually copy that logic from there, the headers and the body, copy that and move it to login. We don't pass the name in the body though, but password and email will be passed. Now there's another small adjustment required. Here, you can actually directly access auth data email and auth data password. Now, if that's saved, go back to your React app and try logging in with the credentials you created a couple of lectures ago. It should work. This error still is coming from the status, which we'll fix soon. And here, we also see that I'm logging something. We see that token that was generated and the user ID. In your Chrome browser DevTools, you can also go to the Application tab, and there go to Local Storage, select your domain, and you will see that token here. That is the token we generated on the server. The other data is data I'm storing here, or that was stored way back by other applications, so we don't need that. That has nothing to do with our app. We have the expiry date, which I generate on the client to know when I should remove the token because it expired. And this is the token itself. Now you can also take that token and visit jwt.io. There you can learn more about JSON Web Tokens first of all. And you can also paste your token into that area on the left. And this allows you to look into your token. You don't see your secret, but you can now validate it. If you enter your secret, which you chose on the server, some super secret, then you should end up with the same token you copied in. And indeed, if I replace it, it does not change. And here you also see that payload data you added on your server side. You could theoretically extract that on the client too, and that is why you should not store super sensitive data in there. But this now also shows you that if I try to generate this token on my own, let's say I also edit it, like change the email address, the token changes on the left, and therefore if I edit this, it will not be validated because now the token is not the same as it was when it was generated on the server with this secret. So if I try to generate my own one with a different secret, I'll end up with a different token. And if I try to edit the data in there, I also do. So I can't mess around with the token in the client. The server will detect this. This is how we can log in and how we work with tokens to know whether we are logged in. We're missing one important piece of information though. We have the token. Now we also need to attach the token to requests that require authentication. Because right now, well, I am logged in. I only see these options after logging in. But theoretically, deleting, editing, and so on does not really care about the token. We should change this. We should also connect new posts to our user. And we should make sure that only users who created a post can edit or delete it. So still some work to do. Now that we're generating a token and we're passing it to the client, we need to make sure that the client can pass back the token to the backend, to the REST API, and we then check for the A, existence, and B, validity of the token before we allow the request to continue. So for example, on our feed routes, on all these routes, none of these routes should be public. So if no token is attached to the incoming request, we should simply block access here. And this is what I'll work on now. For that, I'll add a new middleware. I'll create a new middleware folder for this. You could place it anywhere though. And I'll name it is.auth.js. That is the name of my file. In there, I will import my JSON Web Token package because we'll need that package to validate incoming tokens. Then I'll export one function in that file, and that will be a normal middleware function with request, response, next, so that I can use it as a middleware. And now I first of all need to extract the token from an incoming request. Now currently we are not attaching the token to any requests. How could we attach it? If we go back to our front end, let's say in feed.js for loading posts, we want to attach the token. How could we do that? There are a couple of options. You could add a query parameter, something like token equals, and then enter your token value there, and then append other query parameters. That would be a valid option, nothing wrong with that. You could include it in the request body, but that is not ideal because, for example, GET requests have no body. So that is not a solution you should use unless you never have authenticated GET requests. A great solution is, however, that you use a header. It keeps your URLs beautiful. Of course, that might not be the most important argument, but still, it keeps your URLs beautiful. And a header makes a lot of sense for meta information like, well, the token, which it is in the end. So let's add a second argument in the load posts function in the feed.js file in the front end. A second argument there to the fetch method. And here I will add some headers to this request. Now, I will not add the content type because I'm not sending any data here, but I will add the authorization header. Theoretically, you can add any header you want, but this is an official header, a header you officially use for passing authentication information to the backend. And please remember that on the backend, in the app.js file where we added our course headers, I did enable the authorization header. You need to have that enabled for this to work. So now I'm setting my authorization header there, and I'm setting it to a value which is not just a token, but actually bearer, white space, and then this props token allows you to get the token in the React app. Why bearer? Well, this is just a convention to kind of identify that the type of token you have, and a bearer token is simply an authentication token. You typically use bearer for JSON Web Tokens. It's not a must, you could actually work without that, but it's a common convention, and therefore I want to keep that convention. So this is how I could add my token to that get posts request on the front end. Now on the back end, to extract it in my isAuth middleware, I will create a new variable or a constant token, and then access my request, and with the get method, I can get some header value. The header is the authorization header, of course, and there I will get this bearer whitespace token. Now I'm only interested in the token, of course, so I will split on the whitespace, which comes after bearer, and I'll get the second value, which is the token then. So this is the token. Now I will try to decode that. So I will actually use a try catch block because it could fail. And I will create a new variable here, decoded token. And decoded token will then be JWT, and there you have a verify method. This will both decode and verify your token. You also have a decode token, but this will only decode it and not check if it's valid. So definitely use verify here. And then you pass in that token, which you extracted from the header, and then that secret, and that has to be the same secret you used for signing the token, of course. So the same secret you used in your auth controller, this one. Otherwise, you'll not get a matching result. So this is the secret which we will use for validating the token. Now this could fail. So here I'll have a catch block, and there I want to add a status code to my error of 500, and then I will throw the error here. Since I'm in a middleware, now the Express.js error handler would take over. Otherwise, we know that decoding worked, and now I'll check if it is undefined, which would be the case if it didn't fail technically, but it was not able to verify the token. In this case, I'll create a new error, not authenticated, add a status code of 401, and throw this error. If we make it past this if check, we know that we have a valid token, however, and that we were able to decode it. So now I'll just extract some information from the token, the user ID, and I will store it in the request so that I can use it in other places where this request will go, like in my routes. And there I'll just access the decoded token, which now simply, well, is basically the part on the right here. We can now access that data since we decoded it. So there I can now access my user ID field, which I stored in the token. This will be useful for later, authorizing access to, for example, deleting posts, because now I know the user ID stored in the token, and that should match the user ID of the post we try to delete later. And then I can forward this request. So we'll either have an error if we have no token attached, or everything will be fine. Now we can add that middleware to our routes, and I will add it to my get posts route. So here, get posts should use that middleware. Therefore, I first of all need to import it by requiring it from the middleware folder isAuth, and I will add it like this here. Now I only can get posts if I do add a token. First of all, let me show you how this fails. If I remove this header, so this extra configuration on my get post request in the front end. If I remove that and I reload the page, I get failed to fetch posts, and in the console log I also see that here, because it fails to read split of undefined, we get a technical error because in my middleware it can't get anything from that header because the header is not defined. Therefore, we could add an extra check here and first of all get the header. Auth header would then be request get authorization. And if this is undefined, so if we can't find the header, then I will already create an error here. Not authenticated, because we don't even append the token, so we certainly are not authenticated. I can set my status code of 401, which is better than 500, and I can throw that error. And then down there, we know that we do have the auth header, so now we can split it. So that's an improved way of handling that. Now if we reload on the front end, we still get that error, but technically we now have a 401 error, which is better. Now I can add that code back where I add the token, but let's try adding some rubbish here, which is not a valid token. Now if that reloads, it still fails. And it fails because now the JSON Web Token package has a problem with the format of our token. So now let me revert this and add the valid token. And now as this reloads, now our posts load, because now we are validating this and we have a valid token indeed. So this is now how we can validate on the server side, how we can check whether the token is valid and then grant access. And now we just have to do that for all our routes before we then also make sure that only users who created something can delete it. Because right now, of course, well, I can delete everything, as you can see. We added this isOff middleware on the server. Let's now protect all feed routes with it. Now this is super simple. We just copy that middleware and we add it to every route we have there as the first middleware before we do anything else, because if no token is there, we don't even need to continue with anything else. Every route should be protected here, so we simply add this to every single route. Now once you did add it to every route, you have to make sure that you pass the token on the front end. So this headers setup, where you add this authorization header, this is something you now need to add in a couple of places in the front end. For example, our edit handlers there. There, on the fetch request, we now should also add some headers, and the headers should contain our authorization token. If we scroll down further, we also got the lead post handler. Well, there, obviously, we also want to add some headers, and that one header we want to add is our authorization token. Of course, we can also fetch single posts. So in the single post.js file in the front-end code, where we fetch a single post, we also want to pass that second argument to fetch, add our headers, and there add the authorization header. Now we should be able to navigate around as long as we are authenticated, but I also want to lock down access to ensure that I can only edit and delete posts which I actually created. Now in the last lecture I deleted all posts, so let's make sure that we first of all connect posts and users when we create new posts. Let's connect posts and users. For this, in my backend code, first of all, I'll go to my post model, and there we have that creator object, right? Well, that was like a intermediate solution. Now that we know users in our application, creator will no longer be of type object, but of type schema types object ID, because I will store a reference to a user. So this will now be a reference to a user here. This will also be required true, not required string, what I had before. This was a mistake, of course. So now we have a relation between posts and users. We store the creator of a post in every post we create, and on the user model, we add the post to the list of posts for that user. That, of course, means we now need to adjust our feed controller in the place where we do create new posts. There, in create post, the validation, which we do at the beginning, still is all right. But then before I create the post, I should get my user ID. Now remember, in my isOf middleware, I do actually store that in the request object. I get it from the decoded token. So we have that user ID available here. Now with that information, I'll set creator equal to request user ID. That will be a string, not an object ID, but Mongoose will take care about that and convert it. So now we create a new post assigned to that user. Now, once I save the post, I'll not immediately send the response though. Instead, I now also want to add that post to the list of posts for the given user. Therefore, I'll import my user model into that feed.js file by requiring it from the models folder, of course. And in create post, once we did save the post, I'll use that user model to find the user by ID for the request user ID. So for that user ID extracted from the token. Then I'll return this and close this then block and add a new then block where I now get that user that was created. Now in this second then block here, I now have a user, excuse me, not the user which was created, but the user which was found. I have that user, which is the currently logged in user. And now I can take that user object, which is a Mongoose model here in the end, and I can access the posts of this user. Keep in mind, the user model has a posts property. I can access these posts, and I can push the newly created post. So this post here, I can push that post object to that user. And Mongoose will do all the heavy lifting of pulling out the post ID and adding that to the user actually. Now I'll also add a new variable at the top, which I'll name creator, which is uninitialized. And once I've found a user, I'll store the user in that creator variable. Now what do I need that for? Well, I do update my user here. That means that here I will also call user save and I will return that. And hence we need another then block where I get the result of this operation. Now in this next then block, I'll send my response, and there I will not just send the post, but I also want to set information about the creator. So here I'll add a creator key, and that will be, let's say, some object with an ID, underscore ID of creator underscore ID, and name, which is creator name. So I'm just passing this extra information with the response, and if I want to do that, I have to do it through a variable. So now posts get saved and get connected to users in both directions. Let's try that out. Let's save this code, go back to the front end, and there let's create a new post. Good old duck again. Let's add a duck image. A duck, how lovely. Click accept here, and I get an error. Let's see what's going wrong. I do get back a response with a post, and the problem is that post holds my user data actually, which is a mistake on my side, of course. The post I'm sending back here is not the result. The result here is the user which I updated. Here, post should be the post model, the post object I created up there. So that's my mistake. I do create a post there, I store it in a constant. I can reuse that constant down there to send data about that created post back to the client. So let me save that. Now, still what we'll see is in the database, if I go to the post collection, it was created though, because it only failed when it came to sending back the correct data. And there we see that it's also connected to a user, which ends with ABC. If we have a look at the users, this is this user. And there, in posts, we also find the ID of the post, which ends with 6E5. Yep, that is correct. So this worked. Now only a minor mistake here regarding the data I sent back. Let's simply give this a try again. Here's our post. Let's add a cup. Like this. Super hot. And now this works without an error. So now we are able to connect posts and users Let's now take it a step further and make sure that editing and deleting is only possible for posts that belong to the currently logged in user. To check whether a user tries to edit or delete a post which does not belong to him, we should go to, on the Node REST API project, we should go to our feed controller and there find our update and delete methods, of course. Let's start with updating a post. In there, we find a post by ID, which is all right, of course. And we should keep in mind that for a post, the creator will be the ID of the user who created that. So even if we do have a post here, we want to check whether that creator ID is equal to the ID of the currently logged in user, so of the ID that belongs to the token we received. So here I'll check if post creator is equal to, creator to string, to convert this to a string, is equal to request user ID. So to the user ID I got from my token. If that is equal, I'm allowed to continue. If it is not equal, hence we need an exclamation mark here, I'll throw an error. So here I'll create a new error, not authorized. Set the status code to 403, which is a good status code for authorization issues, and I'll throw that error. Now if I save that, let's check that. First of all, let's delete a post which we are allowed to delete, like that duck. If I delete that, now deleting obviously works because we never added any logic to prevent this. Now let me log out and create a new user. We need a different email address. Well, let's first of all try the same one. It should fail. So here I'll just use max. And it fails. Now let's use an unused email address. And it succeeds. Let's now log in with that newly created user. Now let's try editing, because that is where we did add protection, the cup, which was not created by that user. This failed with a 403 error. Let's now log in with the user who did create it. And let's now try editing with this user. And this now succeeds. So now we have this first check in place. Let's now also add it to our delete post logic there. There, I find my post at the beginning. And before we continue, here, I basically want to implement that same check. I'll check the creator, which is the ID of the user, and compare it to the user ID extracted from the token. And if they're not equal, I will throw an error. So now only authorized users should be able to delete the post, of course. Make sure to do that before you clear the image. Now, after saving this, let's go back and delete this. And it succeeds because this was the right user. Let's log out. Let's log in with this user, let's say, and create a new post, a duck, with the image and some content. And let's log out and log in with the other user, the user who did not create it. And let's delete it there. And you see that fails. Now, I didn't implement an error message there, and of course you could also tweak the frontend to not even show these buttons if you're not allowed to edit. But my idea here is to show you how you can protect this on the backend, since of course this is a Node course. Therefore, I deliberately let you do that so that you can see that we can prevent this on the backend. And indeed, we can't delete this now with the wrong user. Now, talking about deleting, there's one more thing we should do in case we do succeed. We should clear the relation of posts and users. If we refresh the posts collection, we only have one item there. But if I have a look at my users there, now the first user has a couple of posts and the second user has so too. Because right now we have no logic to clear posts when I delete them, to clear relations. And we should of course do that. Now, how can we get rid of a relation? Well, we delete the post anyways, so there's nothing we need to do there. But on the user, we need to pull our reference. To do that, we should find the user after we deleted a post, let's say. So here, I'll find a user by ID, and I can use my request user ID here. And I will return that user object in there. Let's grab that code and add another then block where I will have that user mongoose model fetched from my database. Now in there, I will use my user model and there the posts array, and then there is a pull method mongoose gives me. There I need to pass the ID of the post I want to remove. Now I deleted the post already here, but the post ID is still available, of course. So I can pass post ID here. Now I can call save here to save that updated user and return that. Grab the response one more time and add another then block with a result of that operation. And here I'm done with clearing the relation. Now to see that in action, let me actually get rid of all users manually by using MongoDB compass. Also get rid of all posts. And log out here. And let's create a brand new user because we cleared all users. Like this. Let's log in with that user. And let's create a new post, a duck. Use the duck image. It ducks around for sure. And click accept. And before we do anything, let's go back to Mongoose, to MongoDB Compass, I mean. There we can see that this post has this creator, and this user, more importantly, has this post in his posts array. Now I'm logged in with the right user. Let's click delete. This worked. And now if I refresh posts, we got no posts in there because I deleted the only post we had. And in users, this array is now also empty. So now we're clearing this as well. That's it for this module. You learned that when moving from a classic Node application, which I don't mean in the sense of how you built it in the past, so simply just an application where you render the views in the server, that is a classic application because it is what we started with in this course. So if you move from such a Node application to a REST API, you learned that most of the server-side code does not change. You work with validation, files, and so on in exactly the same way as you did with, well, the classic approach. Only the request and response data changes because there you send JSON data, you don't render any views. You also got more HTTP methods available, which you can use to, well, construct your endpoints, your API endpoints. And the most important takeaway is that the REST API server does not care about the client. The requests are handled in isolation, so every request is treated as if it would arrive for the first time. So we don't use sessions. The server, the REST API, does not store any sessions. It does not store any client data. Now that has important implications for authentication. Due to no sessions being used, the authentication works differently. Each request needs to be able to send some piece of data that proves that the request is authenticated. And that is this JSON Web Token, which we generated and worked with in this module. It's a common way of storing some authentication information in a token, a piece of data, which you send to the client, which you store on the client, and which then gets attached to every outgoing request to a protected resource. JSON Web Tokens are signed by the server, and only the server can validate them by using a private key, which is only known to the server. Hence, you can't fake or manipulate tokens on the client. And that's it for this module. We now had a detailed look at building REST APIs, a common form of Node application which you need in a lot of scenarios, and now you have already a very broad tool set which allows you to build extremely versatile and powerful Node applications. We're still not done with the course though, there's more to come. So time to dive deeper into REST APIs and build a complete project or a complete backend for a project as a REST API. And in this project, we'll have a look at things like authentication and other interesting things like image upload, and so on. So what's in this module in detail? We'll plan our REST API, or I'll show you the project for which we'll need one, and we'll then build it together, of course. So in detail, we will implement all the CRUD operations our project needs. So creating, reading, updating, and deleting items in the database and so on. That is what we'll do here. We'll define all the REST API endpoints for this and so on. We'll add validation on the server side to make sure that only valid data gets stored in our database. We'll add image upload so that we still can store images even though we're not rendering views anymore. And finally, I'll also dive into authentication, which will be very important and very interesting too. So let's dive in.